Hey everyone, this is lesson 4-07. I hope you've got these incompleted notes printed out. Stop the video and do that if you haven't. But I'm actually going to begin by talking very briefly about a couple of questions from the 4.06 or 4-06 homework assignment. Number 6, I'm starting with, I made this note here on number 6 about these things called alternate interior angles. That is not a phrase that you have to know. You don't have to learn that phrase. I haven't taught it to you. It is a phrase that we would have learned if we were in the building this year. So you don't have to know that phrase, okay? But what you do have to know, what I have taught you, and we have practiced, and we've seen this a couple times, is that when you have two parallel lines, they're marked parallel right here, right there, there's the arrow saying they're parallel, and a third line connecting them or crossing them. We call that line a transversal, right? That a bunch of angles get created, and all the acute looking angles are congruent and all the obtuse looking angles are congruent. So look, if we strip these three lines out of this picture and just draw these three lines, 1, 2, 3, there they are. Right? And again, these lines are marked parallel, parallel there, parallel there. Well, here's an acute looking angle, and here's an acute looking angle. Those angles have to be congruent to each other. It doesn't matter what you call them. I mean, there is this technical name for them, but again, you don't have to know that. What matters is that you recognize that they have to be congruent, and that's how I got that 75-degree angle down there. And that's what helped me finish the problem. Same thing on the next page, problem number 12. We have virtually the same exact thing going on here. We've got, once again, here are your two parallel lines. Here's the transversal connecting them or crossing them. And again, if we strip those three lines out of the picture, they look like this. Actually, I should have traced that one parallel line farther down. Okay. So now I've, again, copied those three lines out of the picture. I gave you this angle up here as 65. That's an acute looking angle. Got to be congruent to that acute looking angle down there, which again is how I finished solving this problem. I put that 65 in there. Okay. Actually, I'm just now seeing a third problem that has another phrase that I haven't taught you and you don't need to know. Corresponding angles. That's, corresponding in everyday conversation can mean a number of different things. Its meaning is a little bit loose, but not in geometry, not in mathematics is the definition of anything ever loose or fluid or open to interpretation. Okay? It has a very specific meaning for angles in very particular places. But again, you don't have to know that. Okay? What you do have to know is here's two parallel lines and here's a third line crossing them. And that third line goes all the way up there, right? So if I, once again, just kind of strip those three lines out of the picture, there's the transversal. Here's one of the two parallel lines. Here's the other one. I gave you an acute angle measure down here. Well, that other acute angle measure's got to be the same. Okay. Now, this is not the only way to do this problem either. On the other side here, you might have reason to yourself, hey, this 76-degree angle, that's got to be 76 down there. And then that V plus that 76 plus that 41 have to all add up to 180. You might have solved the problem that way. Okay? So parallel lines with transversals. You don't have to know the names of all these different angle pairs. But you do have to recognize angle pairs that are congruent and angle pairs that are supplementary, okay? Let's go on to the lesson for today. Now, here's the first page of the notes, and I'm going to ask you to pause again in a minute and actually try to finish these problems on this page. Don't worry about page 2. We'll get to that together in a little bit, but just the problems on page 1, but a little explanation here before we get going. First of all, that's a triangle symbol right there in red from triangle ABD. and I will highlight it for you here, triangle ABD. We have learned, a lot of you already knew this, we've learned that the three angles of a triangle always add up to 180 degrees. So R plus V plus X, right? So there's an equation that's true based on this diagram. Well, here's another triangle in this picture, triangle ADC. Now let me erase this one so you can see clearly. Triangle ADC is this large triangle here, the one that contains the two others. The three angles of that triangle add up to 180 degrees, and the three angles of that triangle are this one, R, there it is, and this one, whose measure is X plus W, and then finally, this one, whose measure is T. Now, I put the X plus W in parentheses only to draw your attention to the fact that this expression is really the measure of a single angle in the big triangle. Yes, I know it's the measure of two individual angles in the two smaller triangles, but together, side by side, they make up the measure of a single angle in the big triangle. And notice also that angles V and Z have no place in this equation. Angle V is not one of the three angles of this big triangle. The angles of a triangle are the angles that are in the corners of the triangle, right? So these angles have no place in this equation right here, okay? Now there's a linear pair in this diagram right here, V plus Z equals 180, but there's also one more triangle that I have overlooked. And if you can be writing down an equation from that one triangle right now while I'm cleaning up this picture, that would be great, because I'm going to get to it in a minute. Okay. So what is that one remaining triangle? Okay. I wrote an equation from triangle ABD, from triangle ADC, but there's a third triangle in that picture and another equation that we could write from that triangle. Have you found it? I think probably most of you have by now. From triangle BDC, this triangle down here. We haven't really talked about that one yet. We could write Z plus W plus T equals 180. Okay. So now this is what I want you to do with the three remaining pictures when you pause this video in a moment. I want you to write down all the possible equations, all the possible sums of things that add up to 180 degrees for diagram 2, diagram 3, and diagram 4. You don't have to write the triangle names that they're coming from if you don't want to. I'm probably not going to do that when I show you what my results are. But just write out all of the equations for each one. Okay, this is going to take you 5 to 10 minutes probably. So pause the video, and then when you're done with as much as you can find out, then resume the video. Okay. All right. I'm going to assume that you tried all of these as best you can. Here are the results that I got. All right. And if this goes too fast for you, you can, rewind and replay a little bit of this video here. But I found 3 equations from triangles here. 1, 2, 3. There's this little triangle, that little triangle, and the big triangle. And then a 4th equation from the one and only linear pair in this diagram there. Okay. And again, you do not need the parentheses here. They don't really matter. So nobody, and the order of the letters certainly does not matter, right? This diagram, very similar to the first two. There are 2 little triangles and a 3rd large triangle. So here's the 3 equations from those 3 distinct triangles. And then there is this one linear pair here. Okay. Now triangle or diagram 4 is pretty different. There are not just 3 triangles in this picture. There are 4 triangles in this picture and 3 linear pairs in this picture. So let's take a careful look at where all of my equations came from. This first one here, number 1, R plus G plus V, that's this little triangle up there. Okay. And then let's erase that. M plus Q plus G, where's that coming from? That's coming from this little triangle here. M plus Q plus, oh, wait a minute, there's no G there. Did I do that wrong? Right, right. I heard somebody say, yeah, this G right here is a vertical angle partner with this angle here. So if we're calling that G, we got to call that G also. So that's where that second equation comes from. Now, hey, somebody might have wrote this, which would be really great. For this little triangle right here, somebody might have wrote M plus Q plus, and then instead of calling that angle G, which it is, G, because that angle is a linear pair partner with H, somebody might have called that angle there 180 minus H, and that would have to add up to 180. So if you did that, good for you. Okay. Continuing on now. R plus C plus P, where did that one come from? Looks like that one came from this large triangle here. There's one angle in the corner. There's another angle in the corner. There's the third angle in the corner. These angles have no business being in this equation. They are not angles in the corner of that big red triangle. And then finally, I think there's one more big triangle here. Okay, this one. Right, so I started that equation. There's number 4. Here's number 3. That equation with the K plus the M plus the P. Once again, these angles and these angles here have no business being in this fourth equation. They're not in the corners of the triangle. Okay. And then we've got these 3 linear pairs. Let's erase this stuff. We've got G plus H right there. We've got Q plus C right there. And we've got V plus K right there. Okay. Now, why am I asking you to do all this? Okay. I call this I Spy activity. Maybe some of you are familiar with the I Spy picture books, the ones that my daughters and I used to love to spend time with when they were little. Because on tonight's homework, there's no new facts, no new formulas that you need for any of the homework problems. Now, well, there's one slightly new fact. We'll get to that in a little bit. There are no new formulas, that's for sure. Okay? No new theorems or formulas to teach you. But a lot of the diagrams are going to be more complicated than the diagrams you have been seeing in homework problems so far. They're going to involve multiple triangles and overlapping triangles, like in these diagrams here. And they can become more of a challenge in trying to find a particular angle measure that I've asked you to find. This is what can be a challenge about geometry sometimes, is oftentimes you have to see a relationship that exists among things in the picture in order to be able to apply what you know about that relationship and start finding some missing values. I'll say that again. You just have to see something that can be seen. And how do you see it? You got to look around. All right. I can't give you like a formula approach, like for this kind of problem, step 1, do this, step 2, do that, and you'll always get the answer. I can't offer you that. You've got to hunt around for relationships that you recognize. And, here's in this problem, this diagram number 4 here, there's all these 7 relationships that exist. Okay. Maybe the way I set up a diagram like this and ask you a problem, find a certain angle measure, maybe there's one out of these 7 relationships that you have to recognize to get anywhere in this problem. And if you don't see that one, you're going to be completely stuck. Okay? So you have to really hunt. You've got to know the relationships, and you've got to really hunt and look to find one that you can apply your knowledge to. Okay. All right. Page 2 is kind of like everything we've learned about finding angle measures up to this point. This is the last video lesson before the next quiz to come. And actually, we're going to have a partner quiz first, and then we'll have a solo quiz. Okay. But we've had 2 or 3 more lessons now, 3 more lessons since the previous quiz. And so here's everything that you need to know about finding angle measures all on one page, plus one slightly new fact. We'll get to that in a little bit. So you might want to just copy all this stuff down, or you might want to print it out. It's on my webpage, right? Vertical angles are congruent, so A is congruent to A, B is congruent to B. Linear pairs are supplementary, which means they add up to 180. Parallel lines, you've got all that stuff about parallel lines, right? The 3 angles of a triangle always add up to 180. If a triangle is marked with 2 congruent sides, then you have to be able to conclude that, all right, there are also 2 congruent angles in that triangle. And just because I don't have the congruent side marks there doesn't mean that they're somehow not there anymore. In fact, they probably should be there. Okay. And likewise with this equilateral triangle picture, if I tell you all 3 sides are equal, then you must be able to conclude that all 3 angles are equal. And most of you probably remember what all those 3 angle sizes would be. Anyone? Right? 60 degrees. Now here's the one slightly new fact. And I say slightly new because I think all of you pretty much know the meaning of the word bisect. Okay. Although some of you might have a close idea of the meaning of that word, but not a super precise idea of the meaning of that word, because bisect also sounds a little bit like the word dissect, which is something you may have done with frogs or other small reptiles or animals in middle school science. To dissect something means to cut it into pieces. Okay. To bisect something means to cut. By the way, that part of the word is where we get the meaning of cut. Okay. And so if you bisect something, you cut it not into some random number of pieces, but how many pieces? Okay. How many wheels does a bicycle have? 2, right? How many events in a biathlon? 2. If you are I've lost my pen again. If you are ambidextrous, although we pronounce that ambidextrous or ambidextrous, you have equal dexterity in both of your 2 hands, right? To carry on with this, because I love language, if they're talking about politics and they say, this was a bilateral effort on the part of Congress to pass this bill, that means 2 sides of Congress, meaning the Republican side and the Democratic side both worked together to pass this bill, which is not always the case. A lot of times a bill gets passed, let's say the Republicans are in control of Congress, and they have the majority votes, and so they all vote yes on a bill. The Democrats all vote no, but it passes because the Republicans have the majority, or vice versa. Okay. But when they work together, they call that a bilateral effort. Or if you hear about a bilateral commission, it's a group of people that are made up of people from Republicans and Democrats. So if a segment bisects an angle, enough with the language lesson, right? Come on, Mr. Until, get on with the geometry. You cut an angle into 2 pieces, but even more than that, you cut it into 2 congruent pieces. That's the meaning of the word in geometry. Not just any 2 pieces, not one angle that's 30 and another angle that's 50. 2 congruent angles. Okay. So, looking at these notes here, if you are told that segment AB bisects angle QAM in this diagram, so here's angle QAM, that large angle right there. If you are told that this segment is bisecting that angle, that means it's cutting that angle into 2 smaller congruent angles. that means this angle QAB must be congruent to, let's get another color here, this angle BAM. Those two angles are congruent to each other. And let's get a third color here. Let's make it green. That angle congruent to that angle. Okay. That word or that phrase, bisects an angle, is going to show up in a couple of the homework problems tonight. And I want you to know what that means. Okay. That's the lesson. Good luck on the homework. Message me with any questions and get ready for the partner quiz. The partner quiz is going to include everything we've learned about angles. So you might want to review any and all homework assignments 3.1, 2, 3, 4, and 5, and then 4.5, 6, and 7. All of that stuff. But rather than trying to go over all of those assignments, here's what I recommend. Look over your quiz 3-05 because that had everything in it. Okay, look over the part 1 and the part 2. That had everything in it from the last quiz, and it's all going to come back on this quiz. So review that quiz. Try to learn from any mistakes that you made. Maybe you already have, okay, but review that. And then review the individual assignments 4-5, 4-6, and 4-7. All right, we'll see you soon.